Okay, so before we start the test, we're gonna need to know a few theorems. So one of the more important ones is this one. So this one, the conjugate root theorem. So right here. So remember that one. And also you're gonna need a few of these logarithm formulas. So, but those ones are only less important. It's mainly this one. All right, so
Okay. Can you guys all see it?
Yeah.
Okay. 2021 AMC 12B, problem 10. So question. Two distinct numbers are selected from the set 1, 2, 3, 4, all the way to 36, so that the sum of the remaining 35 numbers is the product of these two numbers. What is the difference of these two numbers? A5, B7, C8, D9, or E10. So solution. So to find the sum of all the integers in the set, we use the formula n times n plus 1 divided by 2. And using this formula, we know that the sum of all the numbers from the set is equal to 37 times 38 divided by 2, which equals to 730. And now, if we take away the two numbers that are missing from the equation using algebra, it becomes 703 minus x minus y, which equals to x times y. And so after we rearrange this equation, it becomes xy plus x plus y equals to 703. After doing this, we can add 1 to each side so we can factor 703 easily and easier. So the equation becomes x plus 1 times y plus 1, which equals to 704. And so after factoring 704 becomes 2 to the power of 6 times 11. And now all we need to do is find numbers that solve this equation. And we can play around with 2 to the power 6 times 11 and rearrange 2 to the power 6 times 11 to 22 times 32. And 22 times 32 also equals to 704. And so after we plug the numbers into this equation, x plus 1 times y plus 1 equals to 22 times 33. X plus 1 equals to 22 and y plus 1 equals to 32. And after we use algebra to solve this, we get x plus 1 minus 1 equals to 22 minus 1, and y plus 1 minus 1 equals to 32 minus 1. And therefore, x equals to 21 and y equals to 31. And 31 minus 21 equals to 10. So the difference between the two numbers is E or 10. And the next question is 2021 AMC 12B problem 2. A question: at a math contest, 57 students are wearing blue shirts and another 75 students are wearing yellow shirts. The 132 students are assigned into 66 pairs. In exactly 23 of these pairs, both students are wearing blue shirts. And how many pairs are both students wearing yellow shirts? A 23, B 32, C 37, B, that's a typo. It should be D and E. And so solution, there are 46 students paired with a blue partner. Since 23 pairs of blue shirts equals to 23 times 2, which equals to 46. Then we do 57 minus the 46 blue shirts. We get the 11 other students who are wearing blue shirts. These 11 students must each be paired with a partner wearing a yellow shirt, since only 46 students are in pairs with blue shirts. We do 75, which are the remaining, minus 11, which equals to 64, to get the amount of students remaining. And finally, 64 students divided by pairs 2 equals to 32, or B, which is the answer. Are there any questions?
All right, good job, Alan. All right, now it's me. So let me share my screen. All right, so this is 2021 AMC 12B problem 9. So the problem was, what was the value of log 280 over log 42 and minus log 160 divided by log 22. So we can remember back for the theorems. So it's kind of hard to deal with the logs like this. So we want to move the divisor. We want to get it out. We don't want it to be a divisor. We want to like not have fractions. So we, hold on, I'm sharing the wrong thing. So, all right, let's see. So we're gonna have the logarithms. So basically, as you can see here, based on this formula right here, we can change this from a fraction into a just plain multiplication. So we use that, this becomes 1 over log 240. And we do the same thing to the other denominator on the other side. So that becomes log 220, 1 over log 220. And so when you're when you're dividing by something less than 1, it becomes multiplication. It's the same as multiplication, so that means we can rewrite it into multiplication form like this. Oh, that's the wrong one. Like this. And we can do the same thing for the other ones, for the other one. And we can also split the logarithm by doing 2 multiples of the original number. So 160 can be split into 16 and 10. So we can do that. It's a lot easier to handle. And so log 2 160 is now become this, and log 220 stays the same for now. So that is equal to, again, we do the same thing for log 280. We split it into 2. And we want to have as many log 210s as possible so that it's easier to handle. So we just split these two. We split log 280, also log 240. And that, so these two right here become these two. And the this stays the same for now. Log 220 stays the same for now. And so log 2 and 8, that's just 3. That the value of that is 3 because 2 to the power of 3 equals 8. So we can instead just write 3 here. This one stays the same because that's not an integer value. And log this right here, it has a value of 2 because 2 to the power of 2 is 4. So we can just write 2 here instead. And same for over here, we have 2 to the power of 4 is 16. So we can just write 4 here instead. And here we can now we can split log 220 into log 210 plus log 2. So if we expand this, then we get this right here. We get this entire thing. And when we expand 3 times 2 is 6. So that, and if we keep going, we can find a few integer values here. Let's see. So basically our goal is to get an integer value at the end, and we want to cancel out all the logs. So once we do that, once we finish expanding, we can simplify. So we can combine some of the log 210 terms because we have a lot of them, and combining them is a lot easier to handle. And so basically we have a bunch of these, we combine them, and we eventually end up with this after simplifying further a lot. And once we end up with that, you can see that this term cancels with this term. So those two are gone. This also cancels with this. Those two are also gone. So what we get is 6 minus 4. And that means the answer is 2. So the answer to this question is 2. And for the next question. So this is 2020 AMC 12B problem 17. And so let's see, the problem was given that R is the root, so the problem, how many polynomials of the form